Hello everyone, welcome back to the Avalon game project. Last time we have refactored our states and simplified the states even further. Now we have only 1, 2, 3, 4, 5 states. We have simplified their logic already, so today we are going to little by little implement the actual service logic. So to recap, the reason why we want to basically inject service into states and to let the state to call service in by the look of it very simple way. The reason by that is we want to separate concerns. So we want the states to only care about the changing of states, the handling of events which could cause transition of states. While for the service, we wanted them to focus on each domain specifically. That's why we have different services. We have game, player, quest, round, communication. So all these, so let's take this game setup for example. This setup does a couple of things. For it, the game the game setup is at the game setup state by default before starting, after created and before starting. It handles two kinds of events. First is player joined, and the second is game started. So before game started, players keeps joining, and each time a player joined, we want to first of all, of course, create a new player, and then broadcast to existing players that a new player has joined. So these can and then so this is a player joint event. So this alone can be separated into two different concerns. First of all, it's the database part where we want to persist the information of a player, for example, their name. We want to, of course, create an ID and ideally a secret for them. And then there's a separate concern, which is to broadcast this to everybody who has already joined. And then when we handle the game started event, we want to first of all assign. So we actually does a couple of different things. First of all, we want to randomly assign everybody a role and let them know which players do they see, and then we notify each individual player about this particular information, and then we broadcast the fact that the game has already started. Now, in this case, I'm wondering if we want to add an exit handle game started. No, this already does it, so it's fine. So yeah, so think about it. When game started, there are also two concerns. First is the database part. We update. So we update all the players because we gave them a role, and we have to record. We have to update the player entities in the persistence layer, and then we want to notify everybody about this. And this is similar to broadcast, but instead of letting everybody know the same information, we basically notify each individual player of a particular piece of information. So the so the idea is that we follow the dry principle, basically do not repeat yourself. We want to further separate these concerns into different services and different methods, but have things like handle game started method to combine those methods. So that in the future, when we do make any change, for example, when the game started, we suddenly decided to also persist. I don't know. Say the timestamp from the client side. Just example. I don't know why do we want to do that, but say we want to add a new value, add a new field to this event, because we have dry principle. We don't really touch, first of all, the state, because the event is an event. We do not touch it. And the state doesn't care about the payload. So we would go into the game service handle game started method to at least to be handled there. But it's also unlikely because handle game started, this would call a method in the game service and some methods from PlayerService. So what we're trying to achieve is that if something changes, we only make the change at one place in the code base and be done with it. Okay, so with all that being said, let's try to implement handle player joined. So this is very simple. Handle player joined. So now we have to write down what we want to do when a player joined. We want to saves, or let's call persists. This sounds fancier. Persists the player and player joined event. Broadcast a new player has joined. Okay. So we create persist the player and the player join event. Persist the player and create a player join event, then broadcast the event. Okay, we persist the player, we create an event, and then we broadcast the event. That's it. So in this case, so when we are dealing with players, we of course need a player service. Right? And wait, we don't have a player service? Oh my god, we don't. That's strange. Player service. Oh no, we are in player service. What? Am I blind? Handle player has joined. Oh right, this is not game service. Oh, I'm so sorry. Totally blind. I'm sorry. Okay, so other than that, actually, we also need a we need a comm service. but we would need the event repository. Or so in this case, do we need an event repository? So okay, the thing is that the idea is that things are hierarchical. Let me see if I can write this down to have some implication. So the idea is that we do things top down. We let the state to handle the highest level of things, so that when it calls the service, it doesn't have anything specific. It just says, okay, handle the game started event, right? So it calls services, and services may, they really should. They also have dependencies. Like for example, the game service is highly likely to the quest service is highly likely depends on the round service, because every time we create a new quest, we would also create a new round, right? But the idea is that this is a layer. So within the service layer, we want, so they of course can have a hierarchy as well, but ideally we want the hierarchy based on the level of domain. So the idea is that the nothing would depend on game service. Well, no other services depends on game service, but game service could depend on the like low, quote unquote, lower level services. For example, the quest service, the game service. Game service already have the player service, the comm service, right? And these services could depend on even lower, like the round service, right? Well, one could argue that these actually belong to the same layer of the round service, because nothing, because they depend nothing, they depend on nothing. They don't depend on anything. Sorry, pardon my English. They don't depend on anything, so that they are actually the very we call it the very bottom layer of services, which is more pure and can be injected anywhere. So let's back to service. So like I said, other than having dependencies among services, they also could depend. Services could depend on repositories. Repositories basically is the database persistence layer. So it would abstract the interaction with the database. So here I have been thinking, how many repositories should we have? So we can of course have as many repositories as the we could have as many repositories as the entities. For example, we could have a player repository. We could have a quest repository. But in reality, this repository is just an interface for others to implement. Why? Because again, here we are implementing the core logic of a game. We do not care what database it uses. We do not care if it has an ID of string or number or whatever. We we have these entities, yes, but so frankly speaking, this should not even so in our game core, we shouldn't even care about, we shouldn't know about a sort key, right? Because in certain database there is no sort key. Yeah, for example, MySQL, regular relational database. You can have different indexes, but sort key is only needed if we were to use DynamoDB. So in this case, we don't even want this here. And so what we're exposed, why? Oh, right, because we have so many things implemented this, but it's not actually used anywhere. Actually, let me see if I can do a. So what if we do this? We simply remove it. Yeah, we have GitHub, so we could just replace all. Replace and see if tests pass. Oh, still some. Replace all. Rerun. Yes. Okay. So so what does this mean? It means that we would expose the event and the repositories out, and of course the state machine to the outside world. So even though we live in the same we would live in the same code base, but outside of this package, all they know is that okay, they have this these entities like called event entity. They have this entities called event, game, player, quest, round, and all sorts of things. And they have a repository with this many method to be implemented. So every time we want to interact with this game core, we would transform whatever we get from the database or outside the world into the format of the predefined event, and use these event to pass to the state machine so that it can pass to the current state. And also we would, so when we create the state machine, we would pass the state machine is actually not this. I actually should delete all these. So the state machine doesn't really care about game service because it wouldn't even do that. So the state machine would require a couple of things. First of all is the repository. So in this case, I have implied that we only want to have one repository, which we define a couple of methods for the outside world to implement. And then we probably need a repository, and we probably need a communication service to be implemented, because we need to broadcast, we need to notify, and all these depends on what the outside world could provide us. Or the comm service could just no, it's fine. So now I only want to have something like this. So we could have self dot com service equals com service, self dot repository equals repository, and then we would create those states, create all these services and all these states, then use the repository to get the current state. And manage states. Yes. Okay. So this is likely that I should also delete this one. This should not have a sort key. Okay. So once we have this, let's go back to the player service. So the player service is likely to depends on a comm service. Because we need to broadcast some event, and it would also depend on repository. So before I thought, okay, let's this is a little bit torn because you know what? I don't like this. I am going to delete this. And we only want to have one repository. And in this repository, we class repository. And this is just a pure class. We don't have any constructor because it has no so yeah, we only want to have definitions. So first of all, of course, we need to have a we get game by ID. Actually, you know what, just get game would be fine. Game ID, I want to give it a string, and what it returns, it should be just a game. But here, the good thing is, we are not going to implement anything, because remember, we only provide this as an interface for the outside world to implement. We could use a relational database, we could use DynamoDB, we could use MongoDB, we could just use a CSV file. It doesn't matter, as long as anything that can support these methods. It's up to the outside world to decide how the actual persistence works. Here we only tell the outside world that okay, we need some mechanism of persistence. As long as you give me these features, and I'm good with that. And by doing so, we basically expose a couple of things to the outside world and keep the independency or autonomy. Autonomy is the word? Is this word? So basically, so we're self-contained. So this is also very. This is another principle I want to mention, which is the open-close principle. We are very open for external to be extended, but very close to changing whatever is inside. We are very open because we we provided these hooks, or not hooks. This is the wrong word. We exposed all these levers, I would call it, that you could pass in a repository, and I would. So let me. Actually, the comm service, I almost want to move it here because this is what we expose to the outside. But you know what? Anyways, I think I'm okay with this for now. So where was I? So yeah, open close. So yeah, so just provide me this comm service and this repository, and I'll give you these events. So we have a contract that you gave me something that implements comm service, and I'll use whatever you give me. Just also, I provide you this repository interface. Oh, by the way, I remember what I wanted to do. This must be an abstract class. No, sorry, that's method. So to define an abstract class, let's just inherit ABC, abstract class. This is literally that. So once we have this ABC, nothing, so this repository class cannot be initiated, so that we can know for sure that only its child classes can be instantiated or initialized. Yeah, okay, so let's take a look at these failures. What are we failing? It is unable to find repositories, I assume? No. Why this is failing? Importing test endgame state, make sure your module. So what module are we missing? So it's line 3. Oh, repositories. Okay, you know what? I think I made a mistake. Let's just do this. Wait, I could. Wait, so I could make this come back. Yep, I definitely could. I love GitHub. Okay, so let's. Doesn't matter. Where are we using it? Game core. Fine. I'll delete it for now. Boo. I'll delete it for now. Okay. So what we will do is let's just, instead of delete it directly, let's do some refactoring. So I will delete this repository. I am going to move it to here. Wait, just refactor. So everything in tests should also be affected. Do we have any repositories anywhere? Repositories. Where were we failing? I can't remember. Doesn't matter. So instead of, so let's then change the name, just file name, just to repository. And then we will change this name to repository. And here we do not need a table. Actually, I would delete the whole constructor. I would then again we inherit from ABC to make sure that we cannot instantiate this class, and let's rename the method to getGame. Okay, so everything is changed. Now all tests are still passing. Very good. So at this point, we want to come back and come back and implement this handle player joined. So we want to persist player service. Of course, we need repository, right? Okay, we have this. I think we deleted this initialize method, so we are good to go. So now we only have this. Wait, something failed. Why? Initialize what? Test game setup. We don't even have that. Test game setup state. Yeah, handle game started, handle player joined, yes. So we want to say that, not, wait, here. So not this, but this is not called. Also, oh, this is test valid event. We want to confirm that the player joined is not called, but we also want to make sure that the handle game started is also not called, right? Refresh, still passing, very good. Okay, let's go back. I'm too easily distracted. Anywho, so we need the repository, we need a comm service, then let's do this. This is the event, return, nothing. So again, we would like to separate this into, why they don't like this? The player join event, not they. So we first of all want to persist the player. We want to create a player joined event and then broadcast the event. So by create, we actually persist this event. So, okay. Another thing, I think one thing we want to introduce is that we also have this event entity. And what is this event entity? So on the client side, whatever we see is an event. So from the very beginning, after we joined, we know who has joined. Like we could pull all the existing events. And at that point, all the existing events is which player has joined. And then, like, let's just look at this from the perspective of the front end. Let's just assume it's a web page, a single page application. We keep seeing players joining, and then we receive an event of game started. Then we receive an event of the game started would contain our row, the players we see, and then we'll see, okay, a mission, a quest has started, a round has started, and the leader of this round is someone, and now we're pending that person to propose a team consists of X players. All those. In case we lose connection or the web page crashes, when we refresh, when we rejoin the game, the first thing we want to do is to fetch all the existing events so that we could reconstruct the game. So in this case, the event should also have a timestamp. Okay, and the oh no. Fine. Right, so I remember this returns timestamp. Yep. Okay, I think this is right. Player service. So we have this event, and so first of all, we want to be able to join event. So this could actually, so first of all, we want to so we first of all validate the event. So once the event is validated, we want to create a player entity. Don't we have a player entity? Okay, we don't. Let's create one. So this we would have an ID, of course. So game, this shouldn't even be called a game ID. This should just be called ID. Same as event. There should just be an ID. We don't really care about the game ID because the game ID again is only required because the DynamoDB doesn't require a composite primary key and sort key combination, right? So of course we're failing things, and why? Because name player is not defined. Then let's define it. So in this we have an ID. Of course, let's import this data class. We have an ID. We should have a name. We of course should have a it must have a row. It really should be an enum. I'm thinking create a constant package to move all the repositories could be deleted. I want to move all the good stuff to there. I think I want to move this to game core constants state name py. Let's see if test still pass. Test still pass. Very good. Now we have stage name. This event type. Let's also move there. And here we want to create another enum called rows. No, just row. We have class row enum. We have let's just define one. Merlin. We need this because eventually we have to. Wait, where is asking me? Eventually we'll have to print out what a row of each player is, so it must be a string value. Player is not defined. Where? Player, okay, let's define it. Entity is player, yes. Okay, not wrong. Okay. So now we want to get player. So once we get the player, we want the repository to save player. Put, because get put, yes, that makes more sense. Put player, and we want the comm service to broadcast the event. Perfect. But so game player. So this get first of all, after validation, we of course dot repository dot put event. We want to put this event, add to it. But the thing is, so the thing is, we can put the game ID, but how? So put event. So when we put the event, do we know or do we not know the game ID? We should be able to, because the event has a game ID field. Oh no, this ID is just ID. Oh Lord. Then we might need a game ID. So in here, okay, this is a 2-bit. No. Okay, we do not care. because the external implementation should be able to figure out what the game ID is, because by the time they receive anything, they know for a fact which game ID they're talking about. So I'm not very concerned. So repository, we have the put event. So now, so this is validate after we put the event. Then once we get the player, no, get player is ChatGPT. Yeah, I think you know the famous word sentence, like in computer science there are two difficult things: cache invalidation and naming things. So okay, need to name a function which parse a payload from an event and create a player entity. I'd like the function name to be short and precise. Build player, I prefer that. Not get player, build player. Build player. Now put player, this makes sense. So let's keep the good stuff going, because we have put event, we have get game. And if I remember correctly, the AWS DynamoDB, the boot core DynamoDB method is, I think they also name it put and get, if I'm correct. Don't quote me on that. So we get player. Wait, what is okay? So we get player. Let's go back. We have and of course we have a broadcast event. Okay. So now leave this. Okay, I think we have something. PlayerService. At this point, we could further implement something. Put player and broadcast the event. No, we can't. No, can we? No, we shouldn't. At least, we at least need to transform this event a little bit. So transformed event equals to self dot transform player join the event. We actually, you know what? Let's build a new one. Actually, I wonder if we want to use this. It should be fine, I think. So in the event, we have the name, we have the timestamp, we have all the good stuff. I don't think Should we or should we not? We should. So in this case, I don't think we need to transform this event because when player joined, the information containing in the event is very simple. It's just the player's name. So I think we can get away with just broadcast the original event. Though for other events we might or might not need to transform it, but at this point we can get away with it, so it should be fine. Okay, so once we have that, let's take a look. Are we doing everything? So first we are validating the incoming event. Once we validate it, we persist the event. So then we use the event to actually build the players, and then persist the player. So once we have the event and player persisted, we are going to broadcast that the a player has joined. Perfect. So now all we need to do is to implement these two methods. So first of all, we need to validate the the payload of the event must contain actually I just realized something. Yeah, we need to transform the event, unfortunately. Why? Because we need to broadcast back the player ID. So we'll have so in this case, we shouldn't even be persisting this event, because whatever event we persist should be the one we give out. So now, so if the event must be transformed, we kind of have to put it later here. So here, let's do this. So after the event is validated, we are going to use that to build a player, and we're using that to we are persisting this player. Then we are going to transformed event equals to self dot player joined event equals to self dot build player joined event, and we're going to, yes, we are going to pass in a player. So once we've done that, we are going to persist the player joined event, and we are going to broadcast the player join event. And we will have to add this method. So again, remember the one with underscore in front of it means it's a protected slash private method. So you'll get a warning if you try to invoke this directly, even from an instance. So yeah, I think we have done a couple of things. We wrapped up again we did some small changes to the structure. We moved things around. We created a couple of new entities, and we're halfway implementing the handle player join method. So I mean, things always get a little bit slower in the beginning because we're establishing different patterns, or just making an example so that the subsequent implementation could follow the same pattern. So it's a little bit slow, and I think I will procrastinate one more day to find a proper package to do validation. But yeah, I think we'll continue the next time. So yeah, I think we had a pretty good day. So yeah, see you next time. Bye.